Welcome to On Rails, the podcast where we dig into the technical decisions behind building and maintaining production Ruby on Rails apps. I'm your host, Robbie Russell. I run Planet Argon, and for over 20 years, we've helped teams maintain and evolve long-lived Rails apps, so I tend to approach these conversations through that lens. I was recently joined by Simone Carletti, the CTO of DNSimple. Simone helps lead the engineering team behind a platform that many of us rely on every day, even if we rarely think about it. DNSimple runs a globally distributed DNS system with a surprisingly small team, and Rails sits right at the center. As CTO, Simone has worked across the stack, from the Rails app to Erlang, name servers to Go services, you name it. So he brings a perspective you don't often hear: how a long-lived Rails app codebase can anchor a system that reaches far beyond a typical web app. Simone lives in Italy, but joined us from his holiday trip in Colombia recently. All right, check for your belongings, all aboard. Simone Carletti, welcome to On Rails.
Thanks, Robbie. Thanks for inviting me.
Simone, so let's start with this. What keeps you on Rails?
Well, that's a great question. So I think that Rails has been really powerful for us over all these years in terms of providing a stable framework that has pretty much everything that you can think of when it comes to web development, and sometimes not just about that. And sometimes they actually lead by providing you guidance and ideas. The other thing that I feel has been pretty important for us is that it's a very active project with a large ecosystem. So for a business, that is very, very important. I don't know how many times happened to you or to the people listening, but you pick a gem, you pick a library, and you do your best effort to find something that maybe is developed by 2 or 3 people, so you don't end up in a single developer.
The one person? Yeah.
Bus factor 1. And then it doesn't matter. The library get replaced or there's the new framework, there's something else. And I've been using Rails for even before starting DNSimple, it's more than 15 years. And it's still here. It's still very much actual. It's still very much on the edge of the web development. And this is really, really important for a success of a company. So I think this is a pretty good foundation for us.
For some context, you don't have to go through your whole CV necessarily, but what other tech stacks have you worked with prior to Ruby on Rails?
So I actually wrote production code in more than 16 languages. I love programming languages. It's something that I, not that much these days, but when I was at university time and when early in my career, I was just trying new languages for fun. Now I wish I had all that time still to try new languages. But it's more like the business is forcing me to get there. But I've been very familiar with Ruby, of course, with Go, with PHP, with Java. I've done a little bit of Python development. And of course, I had some C background as well. And so when I came to the Ruby language more than 15 years ago, it was really, really refreshing to see all the new tooling and all the new passion for active development, something that later on I actually discovered in other languages, maybe slightly differently. There's Elixir, that I use Go. But as I said, regardless, Ruby is still very much modern and Rails is still very much modern and active development. And that is very important for a developer and for a company. So I think that's something pretty cool about this framework.
Before we start peeling back some layers about DNSimple, can you give our listeners a sense of the engineering team behind DNSimple today? And maybe a quick introduction of what DNSimple or DNSimple does.
Absolutely.
I say that all the time, by the way. I think recently I was like, oh, wait, it's just DNSimple, not DNSimple. But I think I've been saying that.
That is correct. Yeah,
the whole time as a customer.
Ironically, I think we strive to make DNS simple, but we pick one of the most challenging names because every time people is confused about that. And over the time, the name also evolved because initially it was DNS simple in the sense like we're making it's DNSimple, but making DNS simple. But then also we open up to domain names. So DNSimple makes like domain name simple. So there's a bunch of various interpretations and even internally. But yeah, sure. So DNSimple in total is about 25 people. The vast majority is still the engineering team. We're about 15 people in the engineering team, give or take. Structure of DNSimple is composed by, I used to say 3 main languages. So we have the Ruby side, which is 50%. more or less. Then we have Go for the 30% of our stack. And then we have Erlang for the remaining 20% of our stack. Each of these three languages actually represent one of our core component of the infrastructure. We can elaborate later if you're interested in, or if it comes through the conversation. DNSimple provides domain and DNS registration. So we started as an authoritative DNS provider. So basically you give us a DNS zone with the records, and we become the provider that serves the DNS record for that particular zone. And then we expanded by providing an additional number of services all around your online identity and online presence. So that would be domain registration, DNS hosting. We also do provide some email services, some SSL certificate services. And really what we strive to do is to bring you all the tools that you need to connect together the services that you use and love, right? We don't want to become the jacks of all the trades, the solution for all your online problems. I feel like there are large companies that do email, for example, very well, and we don't want to become your new email provider. But what we do is that we help you to connect all these pieces together with a strong focus, of course, on the domain side, so the domain registration side and the DNS side.
Coincidentally, when I had my first professional software job, this was back in like 1999, 2000 era, like the year 2000, I worked at a company and my boss is like, hey, why don't you, I know that you like Linux. Why don't you spin up a Linux server? You can be responsible for running DNS for all of, we had a bunch of domains for the company that I work for, and you can manage a Linux server, I think I ran bind on that or something. And so I had a Linux machine in the corner of my cubicle that had an Ethernet connection to it, that had a public IP address. I was responsible for hand coding the DNS bind configurations for a bunch of different domain names. So that was my introduction to working with DNS and stuff like that back in the day. Out of curiosity, what's underneath the hood? Or was any of DNSimple on top of bind or things like that? How does that look? Actually, from an infrastructure, I'm actually just kind of curious, like what's the underlying, because basically DNS, for anyone listening, is like one of the most used APIs, I guess, in a way that,
protocol. Yeah, absolutely.
Yeah,
it's one of the oldest, actually.
Yeah.
It's one of the oldest, and in the essence, is also one of the easiest, although it's actually one of the most complicated because of the number of the RFCs. I believe that I was reading last week about the number of RFCs for, statistics about the number of RFCs per topic. And the DNS space is one of the largest because of it's continuously being refined and new records and new additions, because the web of today is not the web of, 20 years ago.
No.
So in fact, I keep saying the protocol itself is not new. What keeps changing and evolving is the way that you interact with the protocol, right? So you're right. In fact, at the very beginning, DNSimple actually started by using PowerDNS.
Okay.
PowerDNS is one of the two main DNS servers. You have Bind and you have PowerDNS. So our initial infrastructure was based on unicast, and we had a bunch of PowerDNS instances distributed in many servers that we were keeping in sync. But then eventually, it wasn't that much later, around 2012, we started hitting some limits of what PowerDNS back in the days was allowing us to do. In particular, exactly speaking about the way that the web evolved, around 2012, we started to see things like services coming to fruition that gave you a host name, and you wanted to point your name to the host name. So rather than pointing to an IP, as used to be, to the servers, you want to point to the specific host name that that particular service will give you. I mean, notable example, GitHub Pages. If you recall, it was giving you github.io,
right,
and you had your own username, github.io. And so you're pointing your name to that, and you're not going to point to an IP. And now there's a DNS limitation of the CNAME record, which is what usually people use to link to that cannot be used with other records. So in fact, it could not be used for the Apex. So you can have, for example, example.com pointing to your website, let's say GitHub. And so we started to think about alternatives way to execute and to provide this kind of integration interaction. These days, there are RFCs for this type of record. So we came with what we call the alias record. Other companies came with a similar name later on, a name, alias. something like that.
Very familiar with this. Yeah.
Exactly.
It was a challenge at first.
It was absolutely a challenge, but it was a big challenge. So in essence, that's very simple, but it was a very big challenge to make that work, because the way that we had to work with Power DNS is that we had to use pipelines. So we had to inject within the resolution chain, we had to inject some code that says, if it is this type of record, then proceed in this way. And so the very first pipeline that we built was in Ruby, and it didn't work very well. So we then replaced that with other languages. But eventually we realized that it was simply not really that structure back in the days Power DNS to work in this way. So we decided to go with our own, we tried. We built our own name servers. Anthony, my business partner, he was more knowledgeable than me in Erlang. And he says, like, you know what, as a fun project, I want to build a name server with Erlang. And that's how it all started. And so after a couple of years, we actually had our version that was working sufficiently well that we decided, you know what, we're going to put that in production. So around 2014, we switched from Power DNS to what we call DNS, which actually internally we run DNSimple, which is a version on top of DNS, which are our name server, which is also an open source project. So you can go and download that, and you can have your own name servers in your own Erlang ecosystem. And so we've been running it since 2014 in production. We actually recently started to work on that more actively. So these days, in the last year, it's way more active than what I've been in the past years. More modern, more features, because same story, right? Yeah. Pick a language, pick an environment, then time passed, new things comes out, new runtime environment. So you can't really stop more than a few years there. So we're still running it. We use that as a primary name server software. And we still use Power DNS though, but just for the secondary part. So for the AXFR integration, for what allows customers to synchronize their zone from DNSimple to a third-party provider, or from a third-party provider to push the zone inside DNSimple. There is a protocol that is called AXFR, which is the standard protocol for synchronization. And rather than implementing that internally, we rely on Power DNS for the client-server part, essentially.
Out of curiosity, does it help to have two separate DNS servers syncing with each other so that you know that you're staying compliant with like all the RFCs and things like that?
Absolutely. 100%. Yeah. That's actually one of the main benefits that we got lately, because we were able to find, you know what, the DNS space, unfortunately, the number of RFCs is that much that actually sometimes creates more chaos than clarity. And so literally in the last 6 months, we have spent a lot of time working on a topic of the DNS space, which is called empty non-terminals. And the empty non-terminals are a particular, I would say, scenario that happens in the DNS zone and configuration. And we happened to notice that our implementation of the empty non-terminals was not compliant just because we were offering secondary DNS integration. And we realized that the same zone, depending on whether you were querying the primary or the secondary, was returning in certain circumstances different responses. In my opinion, that has been extremely valuable. And I can relate back, just a little anecdote, I can relate back to a major project that we have done around 2014, 2015, which was completely redesigning the API, switching from API v1 to API v2. You know, API v1 were pretty much built in with the early versions of Rails API. So it was, you know, the old XML thing directly inside the controller and multiple responses. And as you start switching from 1.2 to, you know, newer version, things change drastically. So we decided to split off the API in a completely different subcomponent of the Rails application. And when we did it, it was actually the first years that was starting to play around with Go, with a different language. And we decided that we wanted to provide at least 3 API clients. And we started with Ruby. That was the main one, was there since the beginning. Then we decided to go with Go. And it was extremely valuable to build an API and test that. And by test, I mean use it, dogfood that, right? Yeah. Use that using languages and using programming languages that are significantly different in the way that they interact. So Go is a strictly typed. Ruby is not that complex, right? And so by measuring, by testing the API with different languages, we were able to find like, hey, this thing is actually pretty complicated to implement in Go typing. So we might have to serialize this object in a different way. Or we might want to build this API endpoint in a different way. And so in many ways, I feel like going with a heterogeneous environment, would it be two different name server? Would it be two different, DNS providers? Would it be two different programming languages? Actually help you to see things differently, because you are not going to design, strictly influenced by whatever is the tool, the service, or the language that you're using, because you're going to have more than one. And so your brain will not focus on one in particular, and you're going to have the chance, in my opinion, build a better outcome with that.
I think that makes sense for anyone listening out there. If your team has some capacity and the bandwidth to be able to explore those things, like definitely can kind of like unlock ideas that might change how you're implementing it in Ruby or Rails, and then the other technology stacks that you're also potentially working with as well. So I think now that we have a bit of terrain about DNS, and I would love to go more in detail about that. And when it comes to like what parts of Rails, I think you mentioned Rails is about 50% give or take of your technical stack at the moment. So what kind of keeps Rails at the core of a platform that's also using Erlang, Go, and a very distributed infrastructure? I'm assuming you have servers. I don't know if you're running. Maybe we can talk a little bit about the deployment strategy that you currently have as well there.
Absolutely, yes. So, what keeps Rails here? It works really well. That's really the gist of it, right? So, admittedly, we started with Rails back in 2010 when we launched DNSimple, and so the more you move forward, the more it becomes complicated to replace a stack, especially if it works well and you don't have significant reasons to move away. Over the time, we have extracted out some of the things that did not work very well in Rails, or things that we had to implement differently, because ultimately Ruby and Rails are tools like other languages, right? So we always want to start from the perspective of what do we need, and then how do we implement that, rather than like, hey, we have this language, and so we have to implement everything with this language or everything with this framework. So right now, we still use Rails because it works really well for the whole front end and main application side. And the main application is not just the front end and the back end, but actually is the entry point for everything into DNSimple. So when you manage your DNS records, when you register a domain, and of course, as you may imagine, when you go through the billing and all of it, everything passed through the main Rails application, right? Directly or indirectly, would it be through the UI, through the API? And so everything vehicles through the Rails application, even the DNS record, and then ultimately gets propagated all the way to the name servers. And so that component, which is one of the three core components, we have the main Rails application. Then on the other side, we have the name servers, which are the public phase for the DNS queries. And then in the center, we have what we call the zone server. And those are the three core components of our infrastructure. It's effectively, the application is responsible for managing all the interaction with the customer, and then the data is stored in the databases. Then the zone server is the connection between the data and the application and the name servers. Imagine that being like a sort of like a memcached, but designed from scratch to be extremely efficient and focused on serving DNS records. So it is designed to help us replicate the data fast across all our edge, across all the various data centers that we have all around the world. And so that sits in the middle. And those three components, as I was mentioning before, actually represent three main languages. The main Rails application, Ruby, then the zone server in Go, and the name server in Erlang. And each of them, kind of like develop naturally, because every language has its own nuances that makes that really great for that particular use case. Ruby and Rails works really, really well for all the UI front end and also back end interaction, storing data to the database, sending out to queues, sending out to asynchronous jobs. Then the name server Erlang actually turned out it was kind of like a bet. It turned out that the pattern matching of Erlang is one of the best way that you can take an RFC and literally decompose a binary packet of the DNS message by just writing the Erlang definition, copy and pasting from the RFC. So Erlang works really well on that side. And of course, it's tolerant, high concurrency, works really, really well for the DNS side. And then Go for the zone server help us to have a very lightweight process that can load all the DNS zones in memory and help us to process that fast and move the data between one system and the other.
How complicated is like when changes get made for cache expiration? I mean, I can only imagine like if you have that. I mean, I don't know if you know off the top of your head, like how many individual records are we talking about as being distributed across all of your edges right now? Like that's like every like www admin dot, it's like,
yeah,
it's a lot.
Absolutely. No, we're definitely talking about several millions of records distributed all around the infrastructures. But right now we are doing that really, really fast. We actually spent a lot of time 5-6 years ago optimizing the distribution of the changes across the network by making sure that only the delta of the changes gets distributed pretty much as you would normally do with Git, right? So we don't always distribute the same zone. We used to do that, but we don't always distribute the same zone. We distribute just a small delta of the changes, actually not just the changes that you make, because in the DNS space, there is an RFC, there is a topic that is called RR set, which is like a well-defined concept. And so the other set is the combination of all the records that have the same type and name. So in other words, you may be changing one record, but in order to make that efficient, we have to distribute all the other records that are somehow part of the same RR set. But it's still a very small percentage and have a small amount of data compared to distributing the whole zone. We actually have some customers. There's one customer in particular that has one zone with over 2 million records in it. And it would just like kill. It actually, at some point when there were still around 600,000, it started to kill our backup processes, our distribution processes, because serializing all that amount of data, because it's a multi-tenant system. So they were constantly adding and removing records that represent their own customers and the changes that they do in their own systems. And so the changes that we're sending were happening faster than the processing time for us to process the whole zone. So we had to re-engineer completely the distribution of that. And that worked out really, really well. These days, I think that compared to other providers, we can serve large zones without that much of overhead because we really scale pretty much linearly. We don't have that kind of like a linear growth where the more records you have in the zone, the more the impact it is. Of course, there are still some services that ultimately it's data that you have to transfer. For example, there are certain scenarios where we have to completely refresh the zone whenever we reboot certain machines or whenever we provision certain hardware. So we have to refresh entirely the zones. So we still have to go through all the data and deal with the law of physics. That was very funny when we realized that transferring all the amount of data from the main data center that is in Chicago to, for example, Tokyo was the main difficulty that let our server not restart properly. And once we started to actually distribute the data at the various edges, we were able to move from, restarting a machine in 35 minutes to restarting a machine in 60 seconds.
Oh, wow.
And there you learn about the law of physics, like data can only travel so fast.
That makes sense. Just as like a quick little sidebar, what I remember when DNSimple first launched, and I've known Anthony from even before DNSimple in the Rails community, and I remember one of the big benefits of it was that it provided an API for developers to manage their DNS, which is ironic because I still find myself logging in DNSimple and manually adding new records, and I'm like, oh yeah, but we've done a bunch of integration where we would use the API so that when we dealt with like clients that had multi-tenant applications, we had different servers we needed to point them to, we could just manage that through the API. And that was like groundbreaking at the time, coincidentally, just to have a simple REST API endpoint was so helpful. So thank you to you and Anthony for making that much easier.
Appreciate that. And, the API are actually the main entry point for our application. I believe the last time I was checking the stats, I believe we may be serving more API requests than UI requests these days. That's because, when you think about API, you don't have just to think about the normal API integration that you could do with the clients. By the way, we invested a lot by building clients for, I believe, up to 9 different languages to facilitate the adoption of the API and to make sure, because that's our niche, right? DNSimple is a small provider compared to the large 3 players in the industry. And so you need to find your own niche. And our niche was really focused on facilitating automation, not just for developers, but for every company that really wants to get on board with automating stuff. And so the API these days are really the major entry point of our application. And that's actually where Rails help us really tremendously. We still run a little bit of Hanami, which was the framework that Luca Guidi, the friend of mine, Luca was actually working DNSimple for some time while he was developing that framework. So we still have some of that for the API, although there's been some challenge with the version 2 and the upgrades and all of it. And also back in the days, Rails really didn't have the API subcomponent that I believe they introduced 5 to 7 years ago with, a lightweight controller that doesn't come with all the extra things that you don't really need for REST API or for any API at all. And so we are still using it, but really Rails has been extremely helpful here to make possible to have a front end, an API, and all of them sharing the same business logic behind that, right?
Right.
So it worked really, really well. And in these days, there are the clients, but then the whole ecosystem, Kubernetes, and then Terraform, and then infrastructure as code is growing really fast. And it's becoming a key instrumental piece of many companies that want to scale, including DNSimple. It's one of the secrets that help us to scale, pretty much automating as much as possible and using infrastructure as code for everything, including managing our own domains through GitHub. All of that really funnels through the API.
Maybe tell us a little bit about how you approached your, maybe like zooming in a little bit on the Rails app itself. What's that Rails layer look like in terms of like, how do you organize something? You've got controllers, your API endpoints. You mentioned Hanami as well. Where does like controllers and business logic kind of emerge in your Rails app? How do you separate that out? And what's a typical like UI through API business object kind of approach look like there?
Right. So we started like everyone, pretty much having everything in controllers, right? So when we used the first version of the API, the controllers were really containing enough business logic, and the other half was in models. Admittedly, this is one of the things that eventually, as the architecture grow, it can really scale. And for us, the breaking point was when we started to implement an API. Once again, diversification. We built API v2 on Hanami, and Hanami was plugged into the main routing system of the Rails application. So Hanami was a subcomponent of the routing system because it's also a rack application. So, you can mount that on the main router of the Rails application. And so when we started doing that, we came to the problem. It's like, okay, now when someone wants to register a domain, they can do that from the API and they can do that from the UI. If we stuff a bunch of things and business logic inside the controller, it's not going to work, because how do we make that available in the API and vice versa? At the same time, we really wanted to keep them simple. There's a few things that we don't use about models. So for example, no observer and all of that. We use model more in the, I would say, essential talk with the database, return data, and that's it. Do not elaborate too much. We were missing a layer in between, or actually more than one. So we came with a couple of concepts that some of them are still in our application. Others got slightly refined. So we came with the notion of interactors. Originally, we called them command because the idea was to implement the, do and undo command design pattern, but we never did it. We just did the do and never the undo. So we decided eventually to rename them to interactors, which, by the way, I believe is a concept that then was also introduced in Hanami. And really what the interactor is So you have the controllers, which could be the API or could be the UI controller. The controller is responsible for, authentication, all those details. And once the controller knows about essentially who is that wants to perform which action, then pass that action and verifies the permission, by the way, pass that action to the interactor. And what the interactor does is starts orchestrating, working with different layers inside the application. There we have another layer, which we used to call service. Now we are refactoring a little bit, slightly different, but name apart, you can still think about that. It's a layer that it contains the business logic. Every unit of the business, the easiest way to start with was starting from our model. So the logic that you normally put in the model, like for example, let's pick the domain, right? Registering a domain, transferring a domain, enabling a domain, transfer log, disabling a domain, transfer log, all those things that, by the way, also have to interact sometimes with external services like, a registry. So HTTP connection with external services or other type of protocols then sits there. We actually, one of the main rules that we started with was like, no external HTTP integration has to go through our models. That was really the entry point. We said like the model is the interaction with the database. Right. Every layer that is not, which is HTTP or any other interaction, that has to go higher. And so the services are really connecting together the business logic. And then the interactor is the final high level. And each interactor represents a command, pretty much like you normally have a public action on an API or an accessible API on some particular binary or library. Like that's the interactor. So we have one interactor for pretty much every single action that the customer can take from the outside: register a domain, transfer a domain, enable, disable, sign up, unsubscribe, change the card, all of it. And then internally, those interactors will then talk with the various service elements, because when you register a domain, there's many things that you have in common with transferring a domain. Like, for example, setting up the name server for that particular domain name. And so that logic sits into the services. So in many ways, you can think about the interactor being the API that we publicly expose to the users, whereas the services being the internal API of DNSimple as an ecosystem.
Walk me through like a simple example of like, okay, I'm going to add a new domain through the API for onrails.com and send a request to DNSimple with my existing DNSimple credentials, say like new domain, register the domain, that then needs to create a name server. What does that hit in your Rails ecosystem? Is it hitting the interactor or the controller endpoint and then the interactor?
Should pick one of the most complicated interaction names.
Maybe.
It's fine. No, we can start from there. It's fine.
Maybe we can start. Delete one. Maybe that's probably maybe that's actually just as complicated.
No, it's actually a very great exercise. So yeah, the request comes in from the UI or the API, and as I say, the Rails UI or the API have the purpose of abstracting the connection logic, if you want, because in the UI, you have a browser, in the API, you have an HTTP client. But ultimately, in essence, the moment that you go through that initial phase, that would it be the UI or would it be the computer interaction, then what you get is you have a request, which is basically, I want to perform this particular action that maps to a controller and action in both the API and the UI. And I am authenticated or not authenticated as this user, either through the API token or through, basic code or through whatever authentication you have. At that point, we have that request. So that request is sitting within a controller in the API or in the UI. That calls an interactor. And in this particular case, it will call the register domain interactor execute. And the interactor takes the bare minimum arguments that needs, typically the context, which is, the user, whether it's an API request, whether it's a user request, something like that. And then the subject, because the interactor knows what to do. It just needs to know about that particular request. So in that case, it will take a domain name or a parameter that says, hey, the domain name that you want to register is onrails.whatever. And then if there are additional attributes, in this case, settings, like for example, you want to register by turning on then with privacy, you want to automatically, set up certain configurations, then all those settings get passed through the interactor. then internally the interactor will determine, okay, what are the actions that needs to be done? So there are high-level actions like register a domain that on cascade internally will do a bunch of other stuff, because register a domain then requires to verify, first of all, with the registry if the domain is registrable. So there is an initial request to the outside, which is an external entity. And the registry will tell you, for .com, you go to the .com registry, and the .com registry will tell you, yes, this domain is available. No, this domain is not available. So the domain is available. Then that is already a service call, right? Then gets back this particular kind of information. And then at that point, if a bunch of conditions are verified when we go through, so we start interacting with the local application and the local state. So a service will then talk with the database and will create and persist the data about that particular record, then confirm back. And when I say it's complicated, it's because in this interaction, there's actually many services and many rollback points. Because, the registry may say...
Yeah, that's what I was curious about. Is there a transaction for this?
There is a high-level transaction because we use PostgreSQL behind the scenes, but there are certain things that we can roll back at the database level. But let's say that you already send the call to the registry by saying, yes, I accept, I want to register this domain. This is not something that you can easily roll back in a database transaction, right? In complex scenarios, we actually switch to also an asynchronous workflow. So, for example, the registration is one of those. We used to have the registration happening in a synchronous model, whereas these days you can more think about it as a workflow, as a pipeline of actions that are being executed. Each action is a unique true, false, success piece of execution. And then you go through the pipeline one piece at a time. That also helps us with error handling that, honestly, it's a nightmare in this particular context to be able to return back with a meaningful error handling error message at a certain point in time when you have to interact with the various services. So to keep it simple, then services, data layer, at the very end, if the execution succeeds or fails, has a result object. The result object gets sent back to the interactor. The interactor is responsible for passing the result object back to the controller, and the controller gets this result object and knows whether it's a successful result, it's a failed result, and also knows how to serialize that. So if it's an API, then we'll extract the data from this object. So this object, imagine that being like a bag that is passed around, with the various states and the context. And so this object is returned back. And if it's an API, then you extract the domain name, which is a model inside DNSimple from that, and you serialize that. If it's a UI, then most likely that object will be extracted into a UI response.
Interesting.
We are moving away from standard and simple Rails UI, like templates, just because sometimes it's a little bit complex. So we introduced the idea of view models. Actually, these days, I've seen that there's been a few years where I believe it's a new project called Components. It's a library called Components that works really well with Rails. And we pretty much invented that when that library was not available. And so these days, we are more and more thinking about switching away from that custom built library and switch towards component, because we really love when there is something, that works well that we can reutilize and rely upon, because as a small team, it reduced the maintenance burden of many of these topics. It's pretty much what I told you before about Rails ecosystem, right? Rails works really well. And so building on top of Rails help us to focus on what we need. And so building on top of certain libraries help us focus on using those libraries rather than actually maintaining them. And of course, if you build the library only for DNSimple, most likely you're going to miss use cases that are coming from other applications that you can learn from, right? Fresh air coming in and giving you new ideas and bringing you valuable lessons that then you can reuse internally.
You talk about kind of like your approach that you're taking for managing that layer between like your API endpoints, your active record models and things like that. Now you're able to do some of that asynchronous as well, but how is this unlocked? What's your testing strategy there? Presumably you do some automated testing there.
We do.
What does that look like there? And how does this help with that?
Actually, when you were, talking, it was like, as unlocked in my brain, I was already thinking, well, the biggest benefit that we got was testing, because we were able to isolate the testing on each individual responsibility. So, in the controller side ultimately what we care is that the controller is responsible for all negotiating the initial authentication and integration. But then we don't want in every controller test the underlying logic. And so having individual classes that represent, I would say, pluggable components, pluggable unit of code that you can test independently has worked tremendously well for the testing. In particular, when it comes to integrate and interact with external services, because you can't always test HTTP external services you don't test with all the time. In fact, you shouldn't, and you don't want to. And so by having piece of libraries, call them services, call them facade, call them solid components as you want, but by having these elements of abstraction that internally have an API. When you interact with the registry, you define your own API. You say, or when you interact with your billing provider, you say like, I want to add a card, I want to remove a card, I want to charge a customer with this amount, and so on and so forth, right? So you build abstractions, and then the moment that your test hit that layer, then you can cut there and work on the assumption that the moment that there is a guarantee that the abstraction will behave in a certain way, then you can skip talking directly with the external service. Now, of course, the challenge there is that at some point you need to test the integration with that abstraction. Otherwise, you have a bunch of isolated components. And then the moment that you connect them together, you realize that they actually talk a different language because maybe someone has made a change and nothing works. So admittedly, this is challenging. But by having this modular system, we were able to focus on testing effectively the three main parts of the application independently. The API, for what it pertains, the initial connection all the way to having our authenticated user with a request. The UI, same deal. And then the business logic separately. So the unit test can still run on a reasonable amount of time, although it's always too long, you know. Whenever you look at the unit test, you're like, man, can I shrink them somehow?
Are you still running background jobs like it's 2022? That's adorable. Introducing Active Job Premonition, the AI-infused job runner that ships business logic before you even ask for it. No more planning meetings. No more we'll circle back. No more pretending the ticket is the work. Premonition watches your app. That's right, it watches your commits, your support inbox, and quietly enqueues what you're about to need. Churn risk detected, retention flow shipped. Someone says, we need approvals? Congrats. Now you have a workflow with audit logs. You think pricing for half a second, Premonition is already adding validation rules and a dashboard for your CEO. It runs at the perfect time, right after deploy and right before you sleep. Active Job Premonition, because why build the right thing later when you can build the wrong thing early? Side effects may include surprise callbacks, extra states, and your app developing opinions. Destiny not refundable. What does your local development look like when you've got these different systems set up? Are you spinning up containers with the different environments, or how do you work on this thing locally and test that they're all kind of connecting to each other, or is there, you keep them kind of isolated?
We are. So last year, we spent pretty much a huge portion of the year, our platform team, which works on the infrastructure and on enabling the development part, we spent a significant portion of the year by containerizing all the different pieces of DNSimple infrastructure. And there are many of them. I mean, we have approximately 20 to 22, I believe, different components of the application. We have the main raise up, then we have the notifier that finds out the notification in the webhook, then we have the component for the zone server, we have the name server, we have the component that performs the audit logs. So the audit logs are managed separately. It's an external application, an external component, because it's a huge amount of storage and data. So we used to have that inside the main application. Anyhow, with many applications, and so we have worked to have the ability to run the entire DNSimple ecosystem in Docker containers. So these days, anyone can pretty much start a local compose, and that will start all the different applications that you need to have in order to work with. And by default, what's going to happen is that it will start all the different applications. It will set up the main application in the database with a few base data so that you can basically, in a couple of minutes, get up and running and have an entire infrastructure locally running on your machine. And you are able to create a record on the DNSimple application, and then having that being propagated to the instance of the name server so that you could actually run local dig queries, so DNS queries against that name server running on your local machine. So that was a pretty remarkable goal that we managed to achieve. And so the way that now developers can leverage that is that every application could potentially be paused. So let's say that you want to work on the main Rails application and you want to make sure at some most of the time, if the work is confined into the application itself, because you're making a change, for example, to the billing system or something that is just inside the app, then you just run the local development version of the app and it's fine. But the moment that you need to start interacting with the rest of the system, then what you can do, you can go to this composer structure. You can say, I want to start everything except the Rails application. So we'll build up the whole system, ecosystem, and then you start the application in the Rails, in the development environment, and that connects automatically to the rest of the ecosystem. So basically you have the development version of the application running on your machine, and then you have everything else in a containerized environment. Admittedly, we have looked into having developer containers, but we never got there. You know, it's just like we need to balance out the various things that we wanted to work on, and already getting to have the whole infrastructure in a single containerized environment was a huge, huge win for everyone. Not just for us, actually, that was really what empowered us to be able to start looking at external contributors. Historically, DNSimple had never worked a lot with external consultant, neither in the Rails application, nor in the Go environment, nor in the Erlang world. But recently, last year, we started working with some external consultants for example, for the name server. And having this stack entirely containerized really helped not just the DNSimple team, but everyone else coming on board. I'm sure that you do consulting, so you probably know what it feels like getting to a customer
very much
and being like, how do I do that? How can I see that the change being propagated? How can I interact with this component? How do I have access to this? And maybe they don't want to give you access to the source code of that, but a container is a different thing. I can give you access to the container and you can play that in your environment. So that was a huge, huge win for us in terms of scalability.
That makes sense. You know, I think that's an interesting byproduct. We often get called in to help teams improve their onboarding experience because maybe they're trying to hire 50 people in the next year. And they're like, all right, so how can we simplify the onboarding experience so we can spin up the process quicker? Because they're losing a lot of time trying to have everybody read through a bunch of readmes. Okay, set up this, set up this, set up this. Then they're copy pasting things and people make a mistake and they don't know where they broke it along the way. And like, it's a challenge to navigate all that. Like, how do we just have more consistency so we all kind of know that we're bringing 50 new people over the next year, that they are going to have hopefully 80, 90% of the same environment. So we're not like trying to deal with environment specific problems versus not. So definitely can appreciate that. Then you can also, in your scenario, like maybe you can bring in specialists for a very short-term thing. Like maybe you're having a database scaling thing. You're like, hey, we just need someone coming to look at this particular thing.
Exactly.
And we don't have to provide you the whole context of how I get all this thing up. But like, we've narrowed it down. Here's like some containers. Can you look at these weird issues that we're dealing with there?
Exactly. And then yet you also have the opportunity to see everything, right? Maybe you gave a narrowed down access, but still they have the ability to see the final results and not just assume that the change that they have done would work. And also the feedback loop is very different because at that point you can test that directly on your machine without having to wait for someone else to confirm. And I would just want to give a little bit of context here because, you know, maybe someone hearing this show will say, like, well, yeah, container has been around for years, but DNSimple historically has never been focused on containers because the name servers are not containerized. Like the Erlang virtual machine is a virtual machine. It wants as much as energies from your system as much as you give them. It's actually an operating system in its own. And especially in the very early days, the level of networking that we have to do on those machines was impossible to do on any containerized environment because they were abstracting.
Right, yeah.
One of the first things that containers abstract is the network. And guess what we don't want to have abstracted? It's the network, right? So historically, the vast majority of the provisioning and the servers and the software that DNSimple has produced could not be containerized. And still these days, actually, that's not true. We still do not containerize the name server in production, but we did containerize the name server when it comes to running that locally. We cannot deploy a containerized version because, once again, the performance would not be acceptable in that particular scenario. I know it's a very, very specific topic. It would probably work for 99.9% of everyone else. It's one of the specific challenges that DNSimple has to face. And so when you are not used to work with containers and when you are used to work with protocols like BGP that actually do load balancing for you to an extent, then it's often very easy to overlook things that are happening outside of your world, like, hey, containers are becoming a de facto thing. And so we started very late with containers here. And that's also why I'm saying, like, we did not embrace the developer container, whether it would make sense or not. It definitely changed a lot the way that, apart from, building and shipping software, and the whole deployment story is also something that really completely changed the way that we deploy software by going through a containerized environment. But it changed the way that you approach in terms of a team and external people. This is really something that I was not expecting. You often think in terms of code and the product that you sell, but you don't think about the interaction with external people, interaction with onboarding and offboarding, all those things that generally are a little bit higher to the abstraction of a developer. They're generally something where a team lead would focus on, or the business would focus on, right? And so I was very pleasantly surprised to see how much positive benefit it was bringing there. And it reminds me of the challenging when developers tries to sell those topics to their managers, the testing and all of those, and like, they get pushback. They're like, they don't provide value to the final business or the company. So why we need to do tests? And then you have the developer struggling to try to explain how to do it. And that was actually one of those moments where we also realized how much containers help us to work and have DNSimple connect to the external ecosystem.
Out of curiosity, I don't know if you just might have just said that, but just for clarity, did you bring in an external specialist to help with the containerization?
No, we did not.
Or is that something that you're internal? Okay.
We did internal. So we had 3 attempts over 12 years to bring in containerization.
That sounds about right.
The third
sounds actually kind of low from my experience. Okay. I think there's usually a bunch of branches that people tried and I got stuck here. I don't know what to do about the database at this point.
We tried 3 times. The last one was a couple of years ago when one of the team members that joined a couple of years earlier really wanted to push that forward and really took the ownership of that project. And that was instrumental. The team and with proper leadership managed to finally narrow down and focus on what we wanted, define what was the actual goal. And what I said as a goal was exactly what I told you. I want, by the end of this project, to be able to run DNSimple on my machine. That was kind of like the Northern Star, right? That was the lighthouse, what we wanted to build. And so we focused on that by, of course, making choices and then accepting certain compromise or scoping out certain work that would have been amazing, but would not have been essential to get there. And after we achieved that, then we spent a few more iterations by building all the things that we'll have behind that we said, like, you know what, was nice to have. We think it still makes sense. And we implemented that. So it was entirely an internal effort in this sense. We brought in external consultant for building on certain parts of some of the applications.
When you went through that process, did you have to make a lot of application-specific changes to accommodate that?
Yes, we actually had. And the largest one was the Rails application, actually. But once again, it was a byproduct of the fact that the application was designed in an epoch for certain things where certain problems were really not a problem, or where certain scenarios or certain best practice were not really necessary. So, for example, in our previous environment, we were relying on deploying the assets on the same machines that then were serving the application because we had control over the front-end server, the back-end server, and everything else. But when we started to have the application running in isolation in a container, which has an ephemeral file system, we could not deploy the assets anymore there. So we had to perform a few preparatory steps, one of which was shipping the assets through a CDN, which, by the way, once again, is a good thing to have. It's just that we never had enough of a push. Yeah, we
didn't need it,
right?
Yeah.
And so one of the benefits sometimes of adopting these established patterns or tools is that they force you to think in designing the application in a certain way, which ultimately maybe result in having a more extensible and flexible application. So the RAISE application was the largest one that we had to make changes. Probably not as much as we thought. Given that failure 1 and failure 2, I thought that we would have failed 3 because we would have hit at some point. I was really skeptical. I feel like we started rolling out the containerization across all the applications. The Go application are really easy to containerize because you ship a binary already. So containerizing that binary is very, very easy. But the RAISE application is very complex, not just because you have the RAISE application, but because then you have Sidekick behind. So you have the processing system, you have the queues, so you have the API, you have the UI, you have telemetry, all of that combined together. Then I was so skeptical that I said, until I see the application running on a container in production, I'm not going to call it victory, right? And everyone's like, we're almost done. We just need to do that. Hold on. I want to actually be able to say DNSimple.com and see the log in the container and not in our application. But the team was really great in tackling this challenge. And we took one piece at a time. Part of it was also, I would say, we were structured differently. I don't know if we want to expand that, how much time we have, but we were structured differently also in the way that we approach problem. Since 3-4 years, we started to adopt ShapeUp and some of the methodology around it. I'm not going to say that ShapeUp is the best and it's better than everything else. And so by using this, we were able to succeed, and previously we did not. But just by being organized in a certain way, we were able to tackle certain challenges differently.
If I recall, when we had a previous conversation, you mentioned that you have is it like a rotating bench? Is that right?
Right.
For your role? What does that look like?
This is one of the various customization that we did to ShapeUp, because ShapeUp was born really to be something that you design features, right? So it was built at 37 Signal Basecamp. So let's say you want to build a new calendar feature. I believe that's the example in the book. Then you take that feature, so you go through the requirement gathering and everything else, and then when you pass the shape to the builders, you have the builders have the ability to make decisions, and also the scope in the context of that can be reduced. DNSimple is an operational company, and so while we have features, then many of the challenges that we face are also on the operational side, and so we try to adopt a similar methodology also for our platform team. And what we realized also, if you just focus 100% of your time in building and in any other, framework, would it be iterations, would it be any kind of like framework that requires you to be focused on that topic when you're working, then there's a bunch of operational topics that happens every day that you don't get covered. So for example, what happens when there is an incident? What happens if there is a request coming from a customer that has a bug that is actually preventing them from moving forward and maybe losing their assets? There are certain categories of risk that we have codified in DNSimple, like anytime that there is an issue that puts one of the customer assets at risk. So for example, your domain is at expiration and it's at risk of expiring and getting lost. That's a stop the world thing. And in an environment like ShapeUp, there's no stop the world thing. Otherwise, you lose focus. So what we realized is that there are operational challenges every day that cannot be satisfied by having 100% of the team dedicated on building. So we came with this concept, which is the bench, which, by the way, we are also refining in 2026. But the idea is essentially that you have a certain number of people allocated to the main build cycle or to the main iteration, Scrum, Agile, whatever you want to do that. But you have a certain number of people booked for that work. And ideally, you don't want to have those people being distracted by anything happening at the company that is beyond the focus that they're working on. So the people on the bench are effectively the people that follow a special queue. The special queue is done by items, issues that are small issues, generally 1 to 3 days unit of work that they can tackle. And they're also not time sensitive. So at any point in time, if something happens to the outside, so for example, there is an incident or a request, of course, we have the on-call team. But the point is like after an incident, we have remediation tasks. And so some of those will go to the bench. And so the bench can at any point in time drop what they're working on because it's not time sensitive, work on those items, and then come back. And again, also the bench is assisting maybe the revenue team needs a report about something in particular, or a customer needs some kind of assistance. And so the bench is there. It's ready to drop the work that they are doing, of course, unless it's another bench item, work on that, and then come back. So all of that is like 1 to 3 days of work. And we've seen that having the bench people along with the people focused on the building really help us to move forward on the operational task.
Is that like a consistent, does everybody end up on the bench at some point, ideally, or is it?
It's on rotation. So yes, the bench is actually also a very great opportunity for team members to get familiar about other different components of the application that they have not been exposed to. Because, there's many pieces of the application that you have not worked on because it's a different feature. It's something that was built long ago. And so being on the bench gives you the freedom. Sometimes it's the freedom, sometimes it's the requirement to go on certain areas that you are not familiar with. But also it gives you the freedom to do that, generally speaking, with a time frame that is not bound to the time frame of shipping a feature. So you don't have certain strict deadline or time schedule that you normally have when it comes to the building cycle.
Something I'm actually curious about, and you can answer it if you feel comfortable. I think that sounds nice in theory, but I know that when there's an incident happening, teams tend to want to be like, well, so-and-so is kind of the expert at this and we're having a fire. So we're going to go bother that person or pull them off of the thing. And like, hey, can you come help take a look at this? And then sometimes they just maybe that's what just needs to happen sometimes. So you can never entirely shield people from that process. But is that something that you feel like you've been able to mitigate a little bit over the years there?
Partially. I think that there are two different aspects of that. One is the actual incident. So for us, an incident is a very specific topic. As an operational company, the incident it's literally something not working on a particular server, one machine being down, something misbehaving, infrastructure not being rolled out. It's not just about the platform team. It's also about the application team, because an incident could also be Sidekick queue is, I don't know, overloaded and cannot process more items than the items that are being added. And so gets saturated, and all of a sudden that has a cascade impact on many other things. So many of us come from an operational background, and that has been extremely valuable at DNSimple because we started the company from the very beginning with a very heavy focus on incident management and operations. Admittedly, it took a long time before we could expose and kind of like bring these good practices all the way to the application team and the development. When I say the application, just as a context, we have two major teams, platform and application. Application is all the development. It's not just a DNSimple app. It's pretty much everything that is development oriented and customer facing. So even the name server are to an extent, development. Platform is internal development, is essentially infrastructure, what enables the application team then to deliver, to build, and it's all about our infrastructure and the structure of our services. So the platform team is coming from operations at heart, right? It's deeply ingrained into their own habits. For the development team, it's less, but because we are a small company, then from the very beginning, we actually enforced a few practices that helped that through the years. So for example, every engineering team member is on call. So we used to have a follow the sun approach where people were on call based on their working hours. But the reality is that we don't really enforce working hours. Today I'm talking to you from Colombia, but I'm generally based in Europe and I'm here for the Christmas holidays. So if I would be follow the sun, then what's my sun? Is it the one that is still in Europe, or is it the one here in Colombia? And that is actually a problem that sounds not very common, but in fact, we encourage team members to travel or to relocate, or things happen, conferences, you may be going to a conference and you may be relocating for a few times. So, and now we have basically 24 hours on call. So it doesn't follow the sun anymore. And everyone is on call, including the application team, everyone in the engineering team. So that really helps getting into the mindset of owning the code, owning the product. And so eventually, then what we have seen is that you start applying this concept of owning also all the way to the code itself, because it's like, you know what, I was woke up yesterday by this component, then we better fix that, right? Sometimes happen naturally that the team member would eventually be exposed or wants to be exposed on certain kind of areas. Sometimes it becomes forced because you end up being on call looking at some particular component, or you are on the bench or something like that. We try to leverage the knowledge distribution by never assigning work to individual team members. So every time that there is a new functionality, new project, every unit of work is made by a small team. So we take 2 people, those 2 people make a small team. They work on that feature. So for example, for shape up, and then they come back to the normal team processing. And that's because in this way, you never have the risk of being like alone, feeling alone in that particular context. And whenever possible, we pair together someone which is an SME, a subject matter expert in that component, with someone else that maybe is not. Of course, it depends whether the priorities allows us to do that, because we're not, having 2 SMEs working together, you generally proceed faster because you have less of the learning curve. But we need this kind of like a turnaround of people to take a look at the various areas of the application, because otherwise it becomes very challenging to operate. Although, admittedly, we have SMEs. So, there are certain components are more familiar to certain, team members.
What does documentation look like internally there?
So that has changed recently, I would say, because documentation used to be, we have every project with a little bit of documentation, the README and a few other stuff, of course, comments, although not too much, in the sense that we don't want to just write in more comments than code. We do that generally for public-facing things like the API client, for example. But for internals, comments are related to, documenting the main structure of that particular library or endpoint or something like that. The main documentation used to be our wiki. So we have an internal wiki where we document. The wiki is divided into multiple sub-wikis. And so we have one for engineering, we have one for revenue, pretty much one for every team. And then we have a main one for DNSimple as a business, where you have the more company-oriented stuff, including the team composition, SOPs and all of it. Exactly. And so the wiki was the main, I would say, general knowledge. So whenever you wanted to know about how the Go project would work, how the Ruby project would work, how the Erlang project would work, you would go there and you will have information about all the linters, all the libraries, or the conventions, standard conventions, guidelines, all the things that you need to know when you develop in that particular environment. This is what I call like the general documentation. And then we have like the tickets also represent a form of documentation if you want. And we structure our flow of work through tickets. That's the way we work. So we have the main business repository that actually has the business projects. And then every team pulls those projects and create their own tickets. So you have index tickets and many other operational tickets. So those represent, I would say, the point in time documentation, whereas the wiki represent the general standard documentation. I said things are changing because what we have seen this year, we started pilot program to adopt the use of AI inside at DNSimple. And we started by doing that internally to leverage our own productivity. I was going to say our own development productivity, but actually it turns out that many of our information are text in repositories. For example, the DNSimple documentation is a public repository that is a nano-C application. Then we have the blog that is a Jekyll application. Then we have the developer side that is Jekyll, once again, is an anonymous application with a bunch of text files. And then we have the repositories with the tickets being markdown content inside the repository. So because a bunch of that is textual representation that is not, I would say, proprietary into a particular service, then we were able to enable not just the development team, but pretty much any team inside DNSimple, including the marketing team that works on the blog post, to operate with tools like Cursor or like Cloud Code, right? Which are normally just mostly designed for developers. But in fact, because we're a highly engineering-oriented company, they actually work well across the entire organization.
Interesting.
And what we found is that we used to have certain documentation, like, for example, we used to document certain aspect of the DNSimple application inside the wiki because we wanted to have everyone access to that. But what we realized is that some of those documentation were highly technical. For example, the documentation that explained how you send out an event, how you log an entry to the auditing log, how you use our internal custom-built abstraction for metrics, logging, telemetry. All of that was in the wiki. But it turns out that having those directly as a markdown file inside the repository itself allows then to leverage coding tools like Cursor and Cloud Code to actually follow those conventions. That was one of the main challenges we had over the years, right? We leveraged reviewers to catch early on, hey, you have hard-coded the string CNAME as a text rather than using the constant CNAME. Now, we can not only have that knowledge built inside the application itself, but we can also have reviewing tools that are maybe AI-powered, taking the next step, because we have review tools that are automated, but then you can move to the agentic workflow where you have local context that feed into the knowledge that this tool then have in order to provide you assistance. And so because of that, we are starting to migrate back some of the documentation that is repository-oriented or context-oriented back inside the context where the people work and code, because that will become accessible to these tools.
You mentioned like that maybe there's other people like that are not like your software developers have access to this in Cursor. Does it kind of potentially introduce a different barrier? Like, are they ever contributing to the wikis themselves historically? And like, that's just a...
Yes.
But they can learn how to do that in Markdown or something?
Exactly. Admittedly, in the very early days, we use GitHub wikis, but GitHub wikis are, I don't know, that kind of... I don't even know if they still have wikis in GitHub. I mean...
They do.
The idea was great because you had wikis built inside, based on Git. So you had versioning and all of it. But the usability was just for engineers and not even that, right? When we started hiring people that were not highly technical engineers, then not just they had to think in terms of Markdown, but they also had to start thinking in terms of like, you don't have a Word alike, like a Google document or a Word alike editor that you can, select and say bold. You have asterisk and asterisk. What the heck is that? And you don't even have a preview unless you click preview. And that was not very usable. One of the main challenges that we faced was like they were not contributing. Yeah. So we switched to a wiki, which is more like a standard classic wiki with a word processor alike editor. I don't know if I can make names, but we switched to that. And people started to get into the idea of contributing back to the wiki, because that's already one of the challenges, right? Like making sure that people outside the engineering team use those tools properly. I was working in consulting companies before, and even, United Nations and so on and so forth. And I'm like, just having non-technical people open a ticket was hard. Sometimes very hard. Having people contribute to the wiki was the first step. Now that they got accustomed to that, they see the potential and it works very well. Then recently we started to showcase what you can actually do the moment that some of those information are accessible to those agents, ideally locally on your machine. And that has really opened up a whole different, wow moment. We literally did that at the last company retreat. We ran a workshop about how to use, AI tools to leverage those kind of capabilities. As part of the program, deploy AI usage locally at DNSimple to foster the productivity. And to the point where people that used to write draft or blog posts in Google Docs and then move them over to the blog in Markdown, I was switching focus. I'm like, you know what? I'm going to work directly with that. And the tooling nowadays are even much better. Even a tool like Cursor or, even the GitHub interface for editing a file is much better than what it was 10 years ago, admittedly.
Nice. We'll have to check back in with you at some point and see how that adoption is going and what else you're learning. A lot is changing pretty quickly in that space.
It is.
I want to zoom back out a little bit. You mentioned SideQ, for example, telemetry. You mentioned like there's 20 different services there. What about like a little bit lower level in your Rails app? Like, are there any gems that you're heavily dependent on and you're super appreciative for getting to that help you out there? Like, what parts of the Rails and Ruby ecosystem are really important components of keeping the Rails application up and running?
Right. So I would go with there's obviously one of the most obvious one, which is Sidekick, has been helping us tremendously in the whole asynchronous job execution. We have been paying the enterprise version for years. I don't even know for how many years. So there's been an excellent project. Moving away from the obvious, there's a couple of notable ones that I want to bring up just because the story behind it. So there's one that I think it's called LogRage. It's a very old gem from Matthias, one of the folks that worked on building Travis. He was actually the CEO of Travis for a long time. So the reason why I'm mentioning it is because, yes, it's a dependency. We're not relying on it. I mean, we could swap it tomorrow. It's an easy library. What the library does, by the way, it plugs into your Rails login system and will format the log into a JSON structured output. You know that you normally have that verbose log that says, hey, the controller has been rendered, how many seconds, and all of that, right? Which is fine for the development. But when you go to production, what you really want to have for good telemetry, you want to have a structured logging. And actually, I learned about structured logging back in, 2014, 2015, I guess, something about it, when I first learned about that gem. Because there was I recall a talk, probably was RaceConf 2016 in Colorado, where Josh Caldevirimis, I hope I'm not pronouncing, another guy from Travis CI, was talking about how they started to do all the structured logging internally. And they built this gem in order to have a different way of structuring the Race log, because Race never had structured logging. And till this date, I believe it doesn't. Although I know that a couple of months ago, they merged a PR that brought some structure, but I believe it's just in events logging or something. I may be wrong. We need to look into that because we are not using Race 8 yet. I believe this is part of Race 8.1. Long story short, I'm particularly emotionally related to this gem because it clicked in our brain. Since that, we switched not just the Rails application, but the whole ecosystem of application that we had into structured logging. That was also the time when friends of ours built, what was the name? Papertrail, one of the very first aggregation tools for logging, right? That you can search and then analyze your logs. And all of that requires structured logging. So that was a pivotal moment in the design of the architecture of the application and everything else. Nowadays, it's pretty much very common. You learn about open telemetry. There's plenty of services that will do structured logging and will help you to combine together telemetry data. I was at KubeCon 1 month ago, and everything was open telemetry and telemetry data and monitoring of the application. But really, that was a pivotal moment. So that gem and the fact that quickly I could connect a simple library that is probably not even 100 lines of code and have the Race logs being printed out as a JSON structure that then parser can decompose and then you can search and filter and aggregate. All that was very, very incredible. So that's one. What else? Well, obviously, I mentioned we are now start looking more and more into libraries that help us to facilitate the good best practices of building an application. So in the very early days, there was Cells, if I recall correctly, that we used for a while, then we don't use anymore. And now there is the components that I mentioned to you. Obviously, big shout out to RSpec that we still use today. I don't know if today, if I would be starting a new application today, I would still use our spec. Maybe, mini test has evolved so much in the last years that probably I would start from it. I am generally a big fan of not going on a fancy or complex gem. Not that I want to define our spec fancy. I definitely define that complex because some of the internals of that library are very complex. But I don't feel, I generally prefer to use the built-in libraries the moment that they are available before going and hitting the limit before going to search and find something shiny and appealing to the outside. And I feel like back in the days we started, 2010, unit test in Ruby was not as powerful. Mini test now it is. And so most likely new project would appreciate the simplicity of that framework. But we've been running our spec so far and it's been serving us greatly. I believe we're about 92% of code coverage. And so you can just imagine the amount of tests that we have.
Is that a fairly efficient test suite to run? Is it pretty snappy in your container environment?
It depends what you define by snappy. I would say that it could be worse and it could be better. There are definitely improvements available, but it runs in CI, I believe, 4 minutes. Like the whole deployment cycle from the moment that you merge in main to the moment that you can actually ship on a machine through our chat ops the whole pipeline takes about 5 minutes. And that includes running all the tests, running the integration test, building the containers, packaging the assets, and shipping them to the CDN. We do that ahead, even if you don't deploy for number of reasons. So all of that happens in 5 minutes. I believe that the test right now runs in about 3 minutes, give or take.
Okay.
The linters and formatters and all of it runs in about 30 seconds.
Okay.
Speaking of which, big shout out also to parallel test. This is another gem that we use that allows you to run multiple processes. So essentially take your test suite, split that into chunks. Exactly, and run them in parallel. And it does that all automatically without having you to define what are the chunks, mix and match. And so you just tell them, hey, I have this amount of test processes that you can run, especially now that there's all multi-core stuff. And then it will take the test suite and we'll run that in parallel.
Who's responsible for maintaining the DNS sound feature? For context for anyone listening, if you're a customer of DNSimple and you go to the record editor in the web UI, there's a way to like click a little button and it'll play a song of all your DNS records, which has been there for years. And I haven't played it in a while, but
it is. So for the records, I'm going to admit for the very first time ever that if it would have been for me, DNS sound would have probably already been taken out from the application. And that would have been a mistake. Because I don't know how, but there's still after like 12 years, I believe we shipped that in 2012 on April Fool's Day. We hacked together that in one of the very first meetup. It was a lot of fun.
It's fun.
And as things got more complex in terms of like an application environment and all of it, I was like, let's get rid of that. And then there was a lot of pushback internally. And the fact that to this day, people are still talking about that, it just like surprised me, right? So clearly I am not the one maintaining it. So we have, it's a low maintenance right now, to be fair, because we came with this idea where we map all the record types to various chords and sounds. And so you can play your zone by just going through this feature here. It's a low maintenance because it requires maintenance only the time that you add or remove records. And that doesn't happen very frequently. In fact, it hasn't happened at all in, I would say, probably in the last 5 years. Although, coincidentally, in the next few weeks or months, we have in the pipeline to add at least 2 more record types. So clearly, we're going to have to go back and figure out what kind of tone.
That's funny.
I'm not even a musician. And so what kind of tone we have to build in order to make that happen. But suffice to say that there's a lot of resistance from Anthony that actually is a musician. So he studied the conservatory.
I didn't know that.
So he was the mind behind that idea. And then Sebastian, the person that works mostly on all the creativity and the UI, say the design of DNSimple, and a few other folks that are more into music. It turns out there's many people at DNSimple that are into music. They are the main, I would say, promoter of this idea.
Just for context, I'm going to take my headphones off, put it in front of my microphone. Maybe I can see if this will come through the sound, or maybe we can edit it in the post. This is the Planet Argon zone. All right.
right. And then there were all the effect, and I believe
Party paw.
There is one effect in particular that actually I am responsible to, because so at some point we were hacking on this thing, and I was scrolling through Twitter, and I saw a tweet from, I don't know, Corey Haynes.
Yeah.
He was also very active in the Ruby ecosystem a long time ago, and there was this thing about a cat just like opening the paws and having all these lights and colors, and so I came and said, like, okay, then we need to have a party paw version of it. And so you also have this version where you click on it and start just going with all the lights and all the different effects. So yeah, it's just like fun little tool that we built, and it's still there, surviving the age.
That's great. Well, thanks for giving us a little backstory on that. I didn't remember that it makes sense that it was maybe a April Fool's thing that just continue to exist for indefinitely. And I can appreciate why Anthony doesn't want it to go away anytime soon. So I kept you long enough, but there's a couple of last questions I kind of want to get to. And before I dig into those, I'm curious, Anthony's been around the community for a long time, and you as well. How has Rails been part of DNSimple's secret sauce? Is there something about the ethos of the Ruby on Rails community that has benefited how you think about running a business even? You mentioned shape up and things like that. Those are things that come up in some of these conversations, but I'm curious if there's anything else that hasn't been touched on that you think might be worth sharing with our audience.
There's definitely an emotional side of it, because I believe that DNSimple was announced at one of the very first RaceConf back in 2010. So, and many of the early adopters were friends that we met at these conferences. Myself, like other team members, have been speakers at many of those conferences. We were kind of like coming back and sharing our stories about what we were building, things that worked, things that didn't work. So there's definitely something about the whole ecosystem, even if many of us move to different direction. Like I step up, so I'm not doing that much Rails development day by day as I was doing in the past. I also approach different languages. I probably have worked more in Go lately than Ruby itself. Many other friends from the Rails ecosystem have done the same. I know many that moved to Elixir, many that moved to Go as well. But still, Rails has been pivotal in sense of not just about, getting things done and being productive, but the whole ecosystem, the whole story behind it. It's something that I'm not seeing when I'm saying Rails. Of course, I'm also part of it. I'm talking about Ruby because Rails itself is strictly connected with Ruby. But there are aspects of the culture and this ecosystem that I haven't seen happening in one way or another in modern framework or modern languages. Maybe yes in languages, but not as much in framework. If you look at the framework in other languages, maybe we can look at Symfony in PHP, and there's very few others that actually got that level of traction. And once again, something that I said at the very beginning, are still here after 15 years, right? Like I used to work in Spring. Yeah. I don't know if it's still around, but definitely things have changed so drastically. Rails is still very much modern these days. So I feel like it's a mix between, that kind of like emotional thing, but ultimately we're running a business. So emotions play a role up to a certain point. Definitely I can say and I'm not the only one here, there are many other companies like Shopify, GitHub that are still using Rails and performing and achieving even greater throughput than what DNSimple does, because in terms of requests, DNSimple is a small portion. The majority of the requests that we serve are actually served through the DNS name servers, right? But when it comes to being productive and enjoying working or on building something, actually Rails still bring that. And in fact, to an extent, I think that also Rails has been keeping us accountable on making sure that we keep up with where the web ecosystem is moving forward, right? Like I'm not saying that Rails is the standard, But I'm saying that Rails, in order to remain on the edge and remain actual, has to keep adopting new technologies, new libraries, new ideas. I don't know if it was your tweet where you were asking about what were the things that, about early days of Rails. I'm like, Scriptaculous. Do you recall about that?
Yeah.
Right. So it's no longer here. Rails had to evolve. RJS, do you recall the RJS views, right? Rails had to evolve from there. And in a few cases, actually, we were forced or inspired to adopt certain best practices by using Rails. In other cases, we did not like what Rails shipped with. And that's also the beauty of it. You don't have to use all of it. You can pick what works for you, and you can decide to just stick with some of the components and not use the others. But also things that we have built internally, like, for example, we spent a lot of time building an internal abstraction that would encrypt secrets, information that we consider secrets, like, for example, private keys or tokens, all of it internally. Then Rails came with that built-in feature. And we are working to switch to that. There are things in Rails 8 that I'm looking forward to, considering Rails 8, Rails 8.1, maybe like, for example, the new pipeline. I'm looking forward to see if we can actually ditch what we have and consider a new Rails 8.0 pipeline. So again, in some cases, Rails has held us accountable on making sure that we don't age too fast. You know what I mean?
It's a good perspective. I've heard variations of that, but I think sometimes it feels like a lot of teams are just trying to keep up, and they feel like, oh, Rails keeps making changes and we have to make changes to keep up with it. But I don't feel like it. I often hear about it in necessarily a positive tone. It seems to be more of a, they were giving us more work. Why do they keep changing their mind on this or that? And like, well, because the web browsers are changing, servers are like, the ecosystem is changing, right? And so it's not
exactly.
It's a moving target. And like, well, can it just work continuously? Wasn't that the promise of the web? I don't know. But even like, you say the same thing about building like a native app for your phone or whatever, and like you have to keep it updated on the iOS versions. Like you can't not touch it for 5 years very often and have it still work.
Right. Exactly. And guess what? You choose that path, right? Like, if you're building software, you kind of like know that the software gets stale, and having something that help you to evolve faster and not have this sense of, oh, everything is stale now. The only solution to get out of this state is to rebuild that in framework X, right? Having something that doesn't force you to get to a point, or even worse, doesn't force you to get to a point where that framework has not been updated in 3 years. Yeah. And you're forced to rebuild everything from scratch. You move to a different library because guess what is no longer supported, or the ecosystem, the community has moved along to another tool, and therefore you are left there, right? Yeah. None of that has been happening so far in Rails. Finger crossed it's not happening. But I would say it's also one of the often underestimated aspects of using Rails as a framework.
I think that's a good perspective to kind of wrap up on. Out of curiosity, if you can share approximately how many domains is DNS or DNSimple managing right now? Is that private information for your competitors to know?
No, I don't guess it's that secret. So the only thing that I need to mention is that it's a combination though, because it's not just domain. I mean, to be picky, you have zones and you have a domain. The domain is the registered one, and then the zone is the DNS part. And both of them are represented, by the way, by the same string, which is a domain name. So, DNSimple.com, it is both. It could be a registered domain the moment that you register the domain through DNSimple. It could be a DNS zone the moment that you host the zone through DNSimple, or it could be both if you're doing both, right? DNSimple, compared to other registrars, has a heavy focus on the DNS side of it, which means that we actually have a large number of domains that are not registered with us, but are managed through us. So maybe you have your own registrar and you prefer to use DNSimple for a number of reasons, and therefore you delegate the domain to DNSimple, and DNSimple will be serving your DNS. So I believe we are approximately getting closer to 800,000, give or take, if I recall correctly, in terms of 800,000, a million of zones. Then the size varies drastically.
Approximately how many requests are coming through on a daily basis for lookups?
So that actually I have along here because I was looking at other stuff. So
any fun stats?
Yeah. So well, in terms of we are serving approximately 72,000 requests per second, DNS queries per second. So it's more or less 190 billion requests DNS queries per month on our origin network. The origin network is what serves the actual DNS queries. Mm-hmm. Then we have the edge network, which is our caching layer and DDoS defense layer. And generally, approximately, the ratio is 1:5. So you can take 190 billion, multiply, I'm not even English native speaker, so I can't pronounce that number in English, but multiply that by 5 and you get an average of the number of DNS queries. So we are up about 72,000 requests per second.
Okay.
Give or take.
Wow.
On average. And then we have spikes and peaks when DDoS attacks happens, then it can go 1 or 2 order of magnitude higher.
So are you logging each one of those requests somewhere and like tracking that back to those original domains somehow? It's like, that seems like a lot of data to write if you were.
Yes, we are actually. We are for a couple of reasons. Well, one, because we love statistics, but for statistics, you normally just log the hit. You would not go as deep as logging, the whole request and everything. We actually do log all of them in real time, and then we keep an aggregate historically, primarily for 2 reasons. One, for the billing side of it, because right now certain plans get billed by query volume. Therefore, we have to attribute every specific DNS query to the owner of that particular zone. And the second reason is because in the last couple of years, we have been building our own DDoS infrastructure, and we are rolling that out. And so therefore, we have to analyze all that traffic in order to identify anomalies, patterns, strategies, and just learn, right? Like feed that data to the system in order to learn, and then being able to proactively send signal about certain anomalies. So we are actively logging all of that. I can tell you it's a lot of data, to the point where we started that work by thinking that we could have 30 days of retention. And then we had so far to shrink down all the way to, I believe, 7 days, because we're generating something about 15 to 20 terabyte of compressed data per retention period. And so that's a lot of data. But it's actually a very fun project that we started a few months ago in like building our own system to aggregate all of that. We used to leverage our tool. Now we're building all of that kernel extension, feeding the data to ClickHouse, and then running a bunch of operations and analytics on ClickHouse.
I'm hearing a lot of companies talking about ClickHouse lately. So another upcoming interview.
It's a very interesting project.
I'm gonna have to talk to those people myself directly. Maybe we'll see a blog post or something. Does DNSimple have an engineering blog or something that we can point people to?
We do. It's the normal blog.
Okay.
It's so our own blog. We have 5 or 6 different categories. We have learning. We have, of course, feature updates and status updates, and then we also have a category that is engineering, and generally all the posts that are more into cool things that we build falls into the engineering side.
Sure.
In fact, just a few weeks ago, I posted a blog post about the ENT, which is what I was mentioning before, right? The whole time that we spend analyzing the different responses related to the empty non-terminals. And so we went into explaining a little bit more into the details about what it is about that. Also, we recently published another blog post about infrastructure as code. It's also a topic that we mentioned here, but we took that slightly to the extreme. So usually people learn about using infrastructure as code for servers and maybe DNS, but at DNSimple, we also experimented quite successfully by using the infrastructure as code to distribute management across the whole team of the GitHub repositories. So nowadays, we no longer have GitHub admins, but we have effectively all the repositories and all the configuration for those repositories tracked in files, again, through infrastructure as code, and managing our own domains and DNS through that. So, for example, all the domain that DNSimple owns are inside DNSimple, but they're also managed through an integration, which is infrastructure as code. So you have a file that defines domain DNSimple.com. These are the DNS record. These are the zones. These are the configuration of the domain, and so on and so forth. So every time that someone has to make a change, actually goes through the standard pull request, validation, approval, all of it. And so we described all that flow as we have done it in the engineering category of the blog.
Awesome. I'll definitely look up those blog posts and include links to them in the show notes for our listeners.
Awesome. And if you have feedback, then reach out to us, send us an email. We're happy to even feedback about things that you want to learn. We have been speaking at conferences for many years. So if anyone is interested in knowing more about DNSimple, then we're open to share.
That's wonderful. I think one of my goals was, aside from getting to get my curiosity by diving in and talking with folks like you within companies, but also to hopefully help connect people to have these conversations amongst themselves. Because I feel like there's a lot of people working in isolation at times, be like, what are you doing over there? How are you solving these types of problems? And I think hearing about how DNSimple's moving more on the infrastructure side of things, even though you've got your web apps and your APIs, things that other people have, and maybe you're building different types of features for your customers than someone building a lot of web-based interfaces or some mobile app devices. Like, how do we make this all work? Like, you're still solving very similar problems, but just very different target user bases, I think. So I think it's good to hear this perspective.
Absolutely. Absolutely. I believe that being an operational company has certain unique advantages and disadvantages. I'm not going to say that I feel it's easier or harder than, for example, building, Git hosting service. Not at all. It's just that it comes with different challenging, especially in terms of expectation from the outside and reaction to incidents. So it's definitely a different perspective, probably not as common as the more common web application, if you want.
Out of curiosity, Simone, is there a software book that you find yourself recommending to peers? Like a go-to programming book?
That's a great question. I admittedly haven't read software book in a while lately. I've moved a little bit higher in the sense like abstraction.
Like, what does that mean? Like, you're just chatting with ChatGPT or Claude? No, I don't need.
No. It's more like I'm less on a day-to-day coding. Therefore, I haven't read many of those books that I used to read in the past. I was consuming hundreds of books, really, almost literally per year. I think that there's actually so many great books that pragmatic programmers keep shipping that every time I feel like I want to buy all of them. But then I would not have the time to read all of them. I'm kind of like an old guy to an extent, so I still feel attached to the Gangle for design patterns book. That is one of the very few books that I still have hardcover and paper copy on my bookshelf. I still vividly recall one of the best books that I read back in the days was about coding in Ruby with quality. I'm trying to remember. I believe it was from Obi Fernandez, if I recall correctly.
Oh, the Rails way?
No, that was one of them. Give me 1 second.
Is it Eloquent
Here we go.
Ruby?
Eloquent Ruby.
Russ Olson. There you go.
Oh, okay. Then it was not Obi. Yes, Eloquent Ruby. I think it was. I really enjoyed that book. I still recall that these days. And that's another one that I have on my bookshelf. And I believe they have recently published a new version, if I'm not mistaken.
For clarity, Obi did write the foreword, and his name shows up first under the title. And then you see Russ Olson's name a little bit further down. But Obi was the series editor on that, it looks like.
Yeah, here we go. Well, then my brain is not completely out.
You were not wrong. No, not at all.
And yeah, I started working in Ruby, I believe in 2005, if I recall correctly. That was when I started approaching Ruby. And of course, the only books that there were was like the Pickaxe book, right? That's a long time ago. So I didn't even recall how many years ago was that book.
We're getting old,
Simone. I'm wiser.
Maybe. I like to think I am, but I trust that you are. Me, TBD. The jury's out. All right. Well, with that, Simone, where can people follow your work and keep up with what DNS? I'm going to keep doing this. DNSimple is building. You mentioned the blog.
Yes.
That seems like probably the appropriate place, and your API documentation.
Yeah, absolutely. Absolutely. So you can keep an eye on the blog. We post their updates and all of it. Then we, on the website, by the way, we also have a page that we rolled out, I believe a couple of weeks ago, where we are listing all the various podcasts and events where we've been talking through. So this one will definitely end up there, because we found that they are a great way. I don't have to tell you that, but they are a great way for people to know more about the insights of it, pretty much similar to conferences, right? Just like a different mechanism. But I love to know more about what it's happening inside at companies, and just like learn about real world stories rather than just like reading a book that sometimes like tells things that in theory are great, but in practice are impossible or very hard to manage, right? And so we've been having the honor of being present at multiple podcasts. And so we have this page where we list all the conversations, and we try to keep up to date with all the things that are happening. And also, the conferences where we have been speaking also on the blog, we generally list them, or in the social media, we link to the various videos and recording. So that's definitely where you can start from. I'm not going to give my personal sites because it hasn't been updated in years. I've been dedicating most of my energies in DNSimple, actually. So many of the things that you can read on blog actually comes from things that we normally post on maybe on my sites, but I'm happy to share that in the context of DNSimple.
Well, I appreciate that. Well, Simone, thank you so much for stopping by to talk shop with us on Rails. I think we've covered a lot of ground today, so I really appreciate that. Hope to talk to you again at some point in the future as well.
Thank you very much, Robbie. Thank you very much for having me, and talk to you soon.
Hopefully we'll bump into each other at a conference sometime, maybe the next year.
Absolutely. I hope so.
All right. Cheers.
Ciao.
That's it for this episode of On Rails. This podcast is produced by the Rails Foundation with support from its core and contributing members. If you enjoyed the ride, leave a quick review on Apple Podcasts, Spotify, or YouTube. It helps more folks find the show. Again, I'm Robbie Russell. Thanks for riding along. See you next time.